All right, I think we're ready to roll. So here's the menu for today. It's going to be a viable structure session. What I mean by viable is that it's going to depend a lot of whether you have questions, what kind of question you have, and what we need to review together today. One thing's for sure, I want to finish that little practice exercise that we had started last time, because this is going to be a good prep for Friday. After that, as soon as we are done with this, I'm going to start the next module. Okay? If you have more questions, then I'll make time to answer your question, but that's completely dependent on what you bring to the table. So this is where we stopped last time. Okay? Last time, I asked you to try to finish this by yourself. We were talking about writing a little ease matching method, and we were going to add it to the class book. And there were a few rules there on how it should be written. So essentially, it's going to compare the title, ISBN, and the author of the book. So if you haven't already, go to Canvas, download the template file, okay, the one that I have on the JGraphs that I'm going to show in a few minutes, and make sure that you have this. How many of you finished it without problem? Okay. That's bad. How many of you have questions about this method? Probably. Okay. Please shoot. That's okay. Please shoot. If you have questions, bring them. The point is, if you didn't do it, that's bad. Okay. But if you didn't do it and you have absolutely no question, you have no clue what we're talking about today, it's even worse because the exam is coming up at the end of the week, right? So that means that we have just a few days, you and I, to mobilize all the troops and make sure that you're ready by Friday, Saturday. Okay? So let's just keep that in mind and move forward like this. So I'm not going to wait on that one. I'm going to go ahead and help you out on how to write it. So what I wanted you to do is go to the class book. Here we go. And right here anywhere, actually, really. Add this is matching method. Public void. Yes. Oops, sorry. My bad. There we go. A little bit better. Public void is matching. And we are going to we are going to take as parameter a book B. There we go. And then we are going to follow the rules from the slide. So the rule from the slide told us you have to test equality of the three attributes. So the three attributes in that case are going to be the author, the title, and the ISBN. So author. So let's do just a giant return. Okay, we don't have to use the if statement here. We're going to do a giant return of this.author.equals and b.author. All right. So that's the first attribute. Then we are going to use logical AND. So AND another condition and a last condition, semicolon. So let me break this down so that it's a little bit more readable. Second condition is going to be this dot. So we have title, I think, dot equals b dot title, and then the last part. This.isbn equal, and the ISBN was a long, yes, it was a long ISBN. Okay, so that's it. So it's not, the first thing I want to do is reassure you, okay? What I'm going to ask you at the exam, it's not pages and pages of code. It's not even 5 lines of code that are so clever that you are going to put them on your resume to show everybody. Okay, like solving a puzzle in an amazing way. No, it's a direct application of what we have been talking about until now. Okay, so adding a method is matching that compares three attributes, direct application, you should be comfortable with that. If you're not comfortable with that, then please use all office hours this week, the maximum that you can. Let's get you comfortable with that kind of stuff, okay? So that when the exam comes, you get rid of those questions very fast, and you have enough time to do even a little bit more complicated questions. So Going back to the slides, if I can. There we go. Going back to the slides. This is a method that we just wrote. So what we're going to do now, and I'm going to use the slides since I wanted to do like interactive coding, but if you are not up to date on the template, that's not going to work out. Yes, question?
Why did you have it as void, not Boolean?
Oh, why did I have it as void in the live coding? Because I made a mistake. It should be Boolean, okay? The instruction, let me double check. The instruction here should say return the Boolean. Yes, I completely skipped that. So it's a good thing that I have a backup on the slide. So Boolean because we want to return true false, right? So remember what we discussed about last time about the equals method? Right? That it was maybe a little tricky to implement, etc. That you had to provide it with certain features, certain properties, because other methods are going to rely on it. What I'm doing right now is I'm writing my own equals method. But I'm not calling it equals, so I'm not overriding the one from object, so that any other class in the JDK that I use in conjunction with my book class is not going to expect that isMatching method to behave a certain way. I have total freedom to define like what it means for a book to match an ebook, for a book to match an audiobook, or for a book to match another book, okay? For example, I can forbid comparison of things that are of different class. I can say an ebook is not an audiobook is not a book. Or I can say, well, let's take the big picture here. If the author title and ISBN match, then maybe this book is comparable to the ebook. Or I could skip the ISBN because it will be different and say if the author and title match, then yes, we have the same pretty much story here that is being told. Okay? Yeah?
So the title .equals is the same as ISBN line equals?
So the ISBN line, we don't use .equals. Does that make sense to you? Or is that the part that is throwing you off a little bit?
Yeah, I was wondering if they're the same thing or if they're different.
So they are different. They are very, very, very different, okay? The equal operator comparison, you use it only on Java primitive data types. So we can use it here on ISBN because ISBN has been declared of the data type long, okay? But the other attributes, like the author, the title, they are string. So any attribute, any variable that is actually what we call a reference data type, you cannot compare them using just equal. You could write equal, but then what you are comparing is the two references to the object, but you are not comparing the contents of the object. Okay? So here we have multiple strings. They may be different objects in memory, but as long as they contain the same text, we are okay. We have to use .equals to do that. Does that make sense? So it's a very, very common source of bugs. So glad you brought that up. All right. So now that we have a isMatching method for the class book, we are going to continue playing with it. So here's what we are going to do in the main. In the main, we are going to declare an ebook before. So we had already some stuff in the main. Okay. If I go back to the code here, there we go. Scroll up to the main. We have a book B1, an ebook B2, and an audiobook B3. So this was the early testing of this code example that we did. Okay, we had one book, one ebook, one audiobook. Now what we are going to do is we are going to try to make ebooks that looks like our book, for example. So B1 is our book class example. We are going to go back here to the slides, maybe. Here we no, wait. There we go. Not responding for a second, but finally it did its job. Okay, so we are going to go back here to the main, and what we are going to do is we are going to create an ebook B4, and this is a copy of the book B1. Okay, same author, Kevin Mitnick, same title. This book is not about hacking, and then same ISBN, and then finally, because it's an ebook, I had to add a little something. Right, I had to add the file format. So the last parameter here, if I take the laser pointer, the last parameter here is that file format that we need for an ebook that we don't need for a book. And now that I have a book and an ebook that I know have the same title, ISBN, author, I'm going to actually compare them. So system.out println, B1.isMatching before, so this is why it's interesting and important that actually the method returns a Boolean, otherwise we will not see anything. So B1.isMatching before, and I'm going to display the result of calling this method. So B1 is a book, right? Call isMatching on B1, pass as parameter before, and then do exactly the opposite. Call isMatching on B4, which is the ebook, and pass as parameter the book B1. These two are going to return the same thing, and they are going to return true. Based on what we wrote, yeah, that makes sense. The title, ISBN, and O4 are the same. Therefore, I'm going to return true. Okay? It's not always the case that if you say B1, for example, B1.isMatching B3 and B3.isMatching B1, it's not guaranteed that it's going to be true. We are going to see that on the next few examples. Okay? As a matter of fact, we are going to play with the implementation of isMatching to show exactly what are the consequences of using overloading, for example, and then using overriding. So we are going to introduce an overridden version and an overloaded version of isMatching in the subclass, and then we are going to see how it changes as a definition of what it means to be matching an overbook. And it's especially important and relevant when you are comparing two objects that are not of the same class. If you just keep comparing two books, for example, that no problem. But if you do, like we did here, comparison of a book and an ebook, and then switch them around, you're going to see how the results are not going to be always consistent. And we're going to try to explain that, make sure everybody is comfortable with that, so that you have a deep understanding of what's going on with both overloading and overriding. All right. Next version of the isMatching method. So we want to write a isMatching method, same thing, returns a Boolean, okay? This time it takes as parameter an ebook, and we want to add it to the ebook class, okay? So the subclass. So the first version we wrote was in the book class. Now we are going to write something in the ebook class, and because it takes an ebook as parameter, well, it's not the same parameter type as the previous version. The previous version took a book. This one takes an ebook. So we are dealing here with overloading. Okay, remember, overloading is same name for the function, for the method, sorry, same return data type, but different number and or type of parameters. Okay. The rule, this method is going to return true if the method is matching from the superclass. So we are going to chain and call the superclass version. Bless you. If that method is matching from the superclass, if that version returns true and the file format is the same, then we return true. So that is to say that the isMatching from the subclass, the isMatching from the what are we talking about here? Ebook class, okay, is deferring to the superclass testing if the author, title, and ISBN are the same, waiting to get the result from that, proper chaining, right, delegating to what the superclass is supposed to be in charge of. And then once those three attributes have been compared, then if the comparison was true, the last check we need to do is we need to check that two ebooks are the same if they use the same file format. And that's it. Okay? So, again, it's not going to be like huge. It's going to be like very, very, very terse, the code. But the difficulty is in really understanding how the chaining is working. So let's take a look together, and then we're going to run the same test that we ran with the previous version. So, the code first. It's even shorter than the previous one. So I write a public Boolean isMatching method. This is going to be inside the class ebook, like the instruction said. And it's going to take an ebook B as parameter. And then I'm going to return what? The call to the super versions, the superclass version of isMatching. So right now I'm overloading, right? This is a version of isMatching that's taking an ebook. What I'm doing is I'm calling the superclass version that takes a book, but I'm passing B, which is an ebook. Is that okay? Yes. It's okay because that's just polymorphism. Okay. So I'm calling the superclass version of is matching on B, and it's going to tell me pretty much if title, ISBN, and O4 are the same. Whatever it tells me, if it tells me false, those of you who studied that with whatever language in COP2512, you know that some programming language, when they evaluate, logical AND expression, they don't necessarily evaluate the whole expression. They try to be lazy, right? So, for example, in the case of the logical AND operator, you know that both terms need to be true for the whole expression to be true. If one of them is false or both of them are false, the whole expression is false. So if my call to super.isMatching B returns false, that's the end of the story. Java is not going to even try to evaluate the second term of the Boolean expression, okay? And we are going to return false, which makes sense. Title is different, O4, ISBN, whatever, false. If that's true, then we are going to look at the second expression, because for the whole thing to be true, it's going to depend now on the result of the second expression. So, file format dot equals b dot file format, same reason than sooner. Okay, we have to use dot equals here because attribute file format is declared out of data type string. So that's a reference data type. And we are comparing here the file format from that ebook B that we're comparing ourselves to the file format of this ebook. And if they are the same, then the whole expression is true, return true. If they are not the same, return false. So we have a true and a false, return false. Okay? And then we run the same test. So B1 dot is matching B4. B1 is a book, B4 is a ebook, right? B4 dot is matching B1. Again, they return both true. It's a little weird now because we are comparing a book and an ebook. So my definition of comparison has been extended since my previous implementation. Previous implementation, I said, you just check those three attributes, title, ISBN, O4. Now I'm saying, okay, you check those three attributes, but you are also checking if it's an ebook, that the file format is the same. Doesn't look like I'm trying to do that here. How would that work actually with the file format? So this is the first stage here where I really need to make sure everybody understand what's going on, okay? And it has to do with overloading, of course, because we overloaded the method. It has to do with also dynamic binding. So we're going to review those things together real quick here. So B1 dot is matching B4. B4 is an ebook. No question there, no problem there. B1 dot. So what is dynamic binding going to tell us here? Dynamic binding is going to tell us B1 is referring to an object of class book. So remember, dynamic binding always looks at the data type of the object itself. So dynamic binding is going to look at what B1 refers to and is going to find out an object of class book. So I'm going to start looking up any method you are trying to call in the class book itself. You are trying to call is matching parentheses B4 parentheses. Okay? So I'm looking up the is matching method in the class book. I've got one. That's the one that we wrote like a few slides ago. So it takes a book as parameter. So yeah, that's a good match. It returns a Boolean. Perfect. And what is it going to do? It's going to compare the ISBN, the title, and the O4. And that's it. End of story. So even though B4 was an ebook, please note, we didn't call the method, the version of the method, the overloaded version of the method in the subclass that takes an ebook as parameter. We reverted back, we resorted to using the good old-fashioned version of the method from the class book that takes just a book as parameter. And that was allowed because of polymorphism. Now, what about B4 dot is matching B1? Again, the logic of dynamic binding, okay? B4 refer to an object. The data type of that object is ebook. So whatever method you're trying to call on B4, I'm going to look it up starting with the class ebook. You are trying to call the method is matching. Well, that's luck for us. I do have an isMatching method in the class ebook. Okay, what does it look like? It takes an ebook as parameter. Well, here I'm passing B1. Ah, man, that's not fitting. What would I have to do to transform B1, a book, into an ebook? What type of operation? Yeah, downcasting, right? Downcasting is the one that we have to be super careful about. That's the one that almost never works out of the box for free. We always have to think a little bit more to make it work, okay? So yeah, Java is not going to do that automatically. So it's going to say, trying to call actually the isMatching method from the subclass is not going to work because you're giving me a parameter that I cannot downcast to the required data type. So if the method from the subclass is not a good match for whatever reason, what do? We check the superclass. Do you have another isMatching for me? Sure thing. I got an isMatching that is an overloaded version that takes a book. Oh, that one takes a book. B1 is a book. Guess what? That call is going to work. So in both situations, that's what's really important to understand, okay? Even if it's still a little blurry right now because I'm going over it for the first time, okay? When you study those slides, go back over that. Run the debugger on this code. Make sure that you understand what's happening, okay? So what's really important to understand is that in both cases, we end up executing the same version of the method, which is a version from the book class, the one that takes a book as parameter, okay? And that's because of all the rules that we have been laying out until now. So I'm kind of like reusing everything that we studied for the last 2 weeks and putting it in one example. The benefit, once you finally understand fully this example, then that means that everything had to click in the material that we covered for the last 2 weeks. So that's what this example is useful. So that's two versions already of isMatching that we have written. One in the class book, one that was overloading the previous one, and that was in the class ebook. Well, guess what we are doing right now? We are going to not overload anymore. We are going to override. So we are still going to add another isMatching method in the class ebook, the subclass again. So we are going to end up with one isMatching method in book, two isMatching method in ebook. And that second isMatching method in the subclass ebook is going to override the one from the superclass. What's the rule with overriding? You have to stick exactly to the definition of the method. So that means the name of the method needs to be isMatching, just like the superclass. The return type needs to be Boolean, just like the superclass. The parameters, the number of parameters needs to be 1, just like the superclass. And the data type of that parameter needs to be book, just like the superclass. So now we're going to have two versions of isMatching in ebook. One that takes an ebook, that's the one we wrote like last slide, and a new one that we're going to write right now that overrides the one from the superclass that takes a book as parameter. So this is getting funky, because now we have all types of parameter represented here. We have ebooks here, book in the superclass. We have three variants of the method. We are using both overloading and overriding at the same time. What is our goal here? Make it as confusing as can be. It's not really a pedagogical goal. Yes, it is, because we make the example as confusing as can be, so that once you understand it, there's nothing I can throw at you during the final exam or at the end of the week that's going to take you by surprise. So this is about how complex it can get in this course. This is not practice easy to have a bad surprise at the exam. It's practice hard so that you have a better time at the exam. So how are we going to make that work? Well, again, it's not about writing a lot of code. It's about really understanding how Java works. Boolean isMatching book B, and that's going to be in the class ebook. Okay? So the main difference is that we take a book as parameter. That allows us to guarantee that we override the version from the superclass. The rules are kind of the same. I'm going to call super.isMatching_B. So I'm trying to get, okay, I'm trying to get the superclass version to first make the comparison between the three base attributes. Just like we did in the previous version, nothing new. In the previous version, I was left with and then I compared the file format directly. But that's because I was taking an ebook as parameter. If I take an ebook as parameter, I know I can find a file format in that ebook. Okay? Now I'm accepting a book as parameter. Book, ebook, downcasting. Okay? So, if I want to do downcasting, what are the steps? Quick review. 1, make sure that what you have in front of you warrants downcasting. So I have a parameter B of type book. It could just be a book. If it's a book, I'm just going to return false. But if it is an ebook, so I test that with B instance of ebook, if that expression is true, if what you gave to me is actually an ebook, well, I'm an ebook, this is an ebook, we can compare file format. We both have that attribute. Okay? So this is what's happening here. If B, the parameter you gave me, is an instance of ebook, then let's compare my file format to your file format, and you have here the downcasting. So the two techniques that I had to use that we studied last week were the downcasting syntax here, parentheses ebook, parentheses B, and the use of the instance of operator to make sure that when I downcast, I'm actually downcasting the right thing. Okay, make sure that I have in front of me an ebook to downcast into an ebook. And I already explained the else. The else is, well, if it's not an ebook, then we don't have the same file format, right? So this is going to return actually different results when we test it. When I do b1.isMatching_b4, what do you think it's going to return? True? Okay, so I've got 1 vote for true. True again. Okay. You guys got it right. It's going to return true. Why? B1 is a book, right? So dynamic binding says whatever you call, whatever method you call, I'm going to look it up in the class book because the object referred by B1 is of that class. So I look up in the class book, and there's only one version of isMatching up there, the one that takes a book as parameter. Okay? B4 is an ebook. When you accept a book as parameter, can you actually pass an ebook? Yes, it's called polymorphism. So here we are comparing the author, title, ISBN, returns true, and that's all we did. So we executed the superclass version. B4 does isMatching B1. What is this one going to return? I got one false here, false. Okay, everybody that answered seems to agree on false. Bingo. Why? Again, it's a why that's important, okay? You got it right, you got it wrong, that's okay with me, but I want to make sure you understand why. So, before is an ebook. So before refers to an object that is of class ebook. Dynamic binding looks up the data type of that object. It says this is an ebook. What are you calling on that ebook? Ismatching. Is there a version of isMatching in the ebook class? Yes, there are two as a matter of fact. One is accepting a book as parameter. That's the one that overrides. And one is accepting an ebook. That's the one that actually overloads. What do we have here? We have a book. So I'm not going to even try some shenanigan with downcasting here. I'm going to just go with the version that takes the book here. All right, so it's not trivial. It's not meant to be trivial. Okay, this is one of the hardest aspect of introductory Java. Okay, like I would say even we're like in the waters of intermediate Java here. You're trying to really get an understanding of how this mechanics of polymorphism ticks inside the language so that you can use it reliably. Okay? What I would like to leave as an exercise, and please come to office hours for help with that, okay? But do that before the exam. What I would like to leave for exercise here is we've just done something for the class ebook. Practice by doing it also for the class audiobook. And you are going to realize this is one of those easy exercises, okay? Well, it's easy. If you understood everything, it's easy, it's trivial. If you didn't understand, then it's going to be useful because it's going to force you to revisit what we just talked about, make sure you understand it and apply it, okay? So either way, it's a checkpoint. It's going to allow you to make sure, yes, okay, I'm good with the material, I can move forward. Yes?
What does instance of do?
Instance of, when you say is, for example, B1 instance of and the name of a class, what you are checking is you are looking at the object referred to by B1, and you are checking if it's considered an instance of that class. So one of the things that I mentioned in passing last time, but I'm going to reiterate over it, to put it like more into the spotlight. Instance of is not the same as checking the class type of an object. Okay? Let's say that your object is of class book. If I say, is that object an instance of book? The result is true. Let's say your object is of class ebook. If I say, is this object an instance of book? The answer is true as well. Okay? The definition of inheritance tells us any subclass is considered to be also an instance of its superclass. An ebook is a sort of book. All right? So it's not the same as if you were asking to the object, is your class, your actual definition class, book or ebook? Then you would get a more accurate answer. Does that make sense? All right. So, same thing that we did for ebook, please do it for audiobook just for practice. And then we have something that is also a good preparation for the exam. So again, I really encourage you to do that one. We are going to work together on it, but I really encourage you to try to attempt to redo it, after we go over it today. So today is going to be the first introduction, and then try to do it hands-on, come to office hours for help, be able to redo that kind of stuff by the exam. That's my advice to you, okay? So what do we have here? We have a reading list. So we're going to add a new class named reading list. It's going to have an attribute list of type array list of book. So if you have already practiced the other practice exercise that we're assigned in this module, this is going to kind of reuse a little bit of this, okay? So we want pretty much a class that contains an array list of book, all right, in an attribute. We are going to use the static polymorphic method that we wrote together at the beginning of this review material. We're going to reuse that method, and we're going to put it actually in our class this time. So we want to integrate it in that class. So we're going to cut and paste, move it, put it in that class. Just to remind you, what this method displayBook did, it accepted a book as parameter, so it was able to work on book, ebook, audiobook, and it just called the toString method on that parameter to have a text representation of that book, audiobook, ebook, and then displayed it on the screen. Okay? Now, what we want to do with this, we want to add a display method to our class, so not a static one, right? The static one is able to display one book. Now we want to add another method that we're just going to call display to that class, and this method is going to go over the list of all the elements that I have in my class and display each of them using the previous method, the one from the second bullet item. Okay? So it's going to iterate over that array list. Make sure you're comfortable doing that by the time of the exam. It's going to call display, what is it called? Display book on every element. It's going to display for me on the screen all the information about all the books, ebooks, and audiobook in the list. Now here's a little extra. If the element that you're looking at, so you're going to look at every element one after the other. If the element you're looking at is an instance of the class audiobook, then I want you to do something extra. So first, you're going to go to the class audiobook. You're going to add a method. We're going to call it pre-download or something like that. It's supposed to be something that you're going to call on every object of the class audiobook that's going to connect to a URL, download the MP4 for that audiobook, MP3, sorry, and that's it. Okay? And we're going to simulate all this by displaying, pre-downloading the audiobook on the screen. once we have this method in the class audiobook, what are we at? Where are we at? We are in a situation where one of the subclass, audiobook, has a method that its superclass doesn't have. Remember, that was the whole point of us like learning about downcasting, etc. So now we're winding back to our method that iterates over every element of the list. Okay, the method display now. I want it to detect when one of the elements is an audiobook. And when it detects that one of the elements is an audiobook, and how do you do that? You do that with instance of. Okay? When you detect one of your elements is an audiobook, I want you to call on that element using downcasting, the special method that you know only that element has, which is pre-download, prefetch audiobook, whatever we are going to call it. Okay? So we are putting together all the structures that we have learned to deal with for the last 2 weeks again. And then test this class, do it exactly like we did, compare, put a bunch of stuff in your list, audiobook, books, ebooks, etc. Some of them are like comparable, some of them are totally different, and then display them all on the screen and make sure that the audiobooks, not only they get displayed, but when they are processed, there is this little message that is also displayed that say preloading, the audiobook, pre-downloading the audiobook for you. How are we going to get that working? Let's take a look. Class reading list has an attribute list of type audiobook of book. So this is, and actually I should have made that private. I don't know why I didn't make it private. This is a polymorphic array list. It's an array list that can contain books, but also ebooks and audiobooks. Okay, that's the idea of polymorphism. If you accept a book, you also accept an ebook and an audiobook. So I can have 3 types of things in that list. Constructor creates the array list. Make sure you're comfortable with that syntax. Every semester there are people that have some difficulty with the diamond syntax and then the parentheses. When do I need the diamond? When do I need the parentheses? If you have questions about that, please bring them up or come to office hours, end of the class. We'll brief you up. But yes, the syntax is looking a little weird. Get used to it. Public void add book B list.addB. What am I doing here? I'm just saying if you want me to add an audiobook, if you want me to add any kind of book, not just an audiobook, I'm going to just ask my attribute to add it to the array list. I'm delegating the work because I do have an array list as one of my attributes that's meant for it to do its job, right? And its job is to store books of all sorts. So again, one statement. It's not even one line of code. It's one statement in the method. If you know how things are working, it's going to be that short to write code at the exam. And then display book. So this is the one that used to be static, right? This was our static method. The first thing that we wrote, if I remember correctly, in this review session last week. Now we have adapted it so that we integrate it into this class. So private void display book B and system.out.println B. Yes, if I ask you to write that, I'm going to go on about polymorphic method, etc. But in practice, it's not that hard. And then public void display. So that's the funny one. That's the interesting one, right? That's the one that's supposed to display everything that is in my reading list. So be it books, audiobooks, or ebooks. And each of them has to be displayed in the manner that is suitable for its class. Which means if I try to display the information about a book, I'm going to call the toString method from the class book. If I wanted to display the information about an ebook, I'm going to call the toString method that is overridden in the class ebook, and so on and so forth. So it starts with a for each loop. So I don't want to take you by surprise. At the exam, you will be asked to use explicitly a for each loop. If you fumble around and you don't know the syntax, etc., and you revert back to a regular for loop, you'll still get most of the points, okay? But you'll still lose a little bit of points. So if you are aiming for the best score that you can get, make sure that you are okay with for each loops by the exam. So the syntax of the for each loop, for each book B inside the list attribute. So for each book B inside my array list. What do I do with it? Display book B. Call to the polymorphic method. it's going to automatically trigger the write toString. Okay, right here, even though I didn't write to b.toString, this is what happens. The toString method is called on b. Polymorphism is going to make it work. If b is an instance of audiobook, so I'm using my instance of technique here to detect if b is actually an audiobook, not just a book or any book. And then downcasting, if it is an audiobook, then I want to look at it as an audiobook. This is what downcasting is about. We change the perspective. So convert b, the reference, into a reference to an audiobook, and then use that reference to call the method pre-download. And it's going to work at compilation time, because we use downcasting, and it's going to work at runtime, because at this point in the code, I made sure that b referred to an audiobook. So I'm going to find the method pre-download inside of it. That's it. Okay? Last but not least, yeah, question? We just add it. I mentioned it in passing in the previous slide. We add it to the method, to the class audiobook, and all it does is print something on the screen that says, I'm pre-downloading your audiobook. So this is the fourth bullet item here that's going to guide you through that. Okay? Good question. Yeah.
So I remember, I think it might have been last lecture, but I remember you said that if we were checking an instance of and that we had to downcast because the instance that while it does that, we have to explicitly downcast.
So with instance of, you don't have to necessarily downcast, but we have been learning to use instance of as a safety before to downcast. You see the difference, right? That means you could use instance of for different things, but if you look at everything we've done with it so far, pretty much we used it always as a pre-step to downcasting. It's what forced us actually to learn about it, is we learned about downcasting, and then we were like, well, this stuff doesn't work, and then we needed to find a way to make it work. Well, it works when you first make sure that, you are dealing with an object of the right class at runtime, and then you can downcast it. Make sense?
Yeah.
Cool. All right. So, again, another practice here. This week we have no new concept. This is entirely prepared for the exam. Okay? So, version 2.0 of reading list. What could we possibly do to help us practice something that we learned in module M3? Yeah? Override it. We did some overriding already with the is matching, right? Is matching, we used it to practice overloading, overriding. What we are going to do now with the class is we are going to make it inherit from, so as part of it is going to also override the add method, but it's going to inherit from array list of book. So there were two practice exercises that I released when we started the second half of module 3. Those two practice exercises were pretty much go back to invoice, go back to to-do list, okay? And now I'm just going to take one of them as an example. In the case of to-do list, I told you, let's not just look at one to-do item, okay? We're going to make a subclass of to-do that is to-do with priority, so a to-do item with priority, and another subclass of to-do which is to-do with assignment, I think. So that means the priority means that you have an int, an attribute int, an extra attribute that allows you to rank the priority of the task. And the one with assignment, you have a string attribute that allows you to keep track of the name to whom this task has been, this to-do item has been assigned. Okay? So we do that, and then I ask you to have a polymorphic list of to-do item instead of just a standard to-do item list. This is like nothing. You have nothing to change, right? You still declare it, as a array list of to-do elements, and that's it. It's polymorphic by definition because now to-do has two subclasses. And the last thing I asked you to do was, and now what about you make it inherit from array list instead of using an attribute of class array list? So go back to those examples again for the exam. Very good preparation. I told you last exam, I said, I'm not going to make you, inherit from array list because it's too recent. We just covered it. This was about 2 weeks ago. Now this is perfectly fair for this upcoming exam, so prepare yourself for this. I don't want you to be taken by surprise. I want you to prepare efficiently for the exam and then get the best grade that you can get. Okay? All right. With that, we've covered our module. We covered all the different aspects of the module in the review as well. Questions? But I tried to close PowerPoint that's crashing on me. Yeah?
Can you go back to the second is matching?
Absolutely. I can try, definitely. Give me 1 second. Maybe open this. Collapse. Okay, this is where we were. So where do you want me to go back? The second is matching. Okay, is matching method that overloads. There we go. This is the one that's supposed to overload, and this is the code. Is that what you needed?
Yeah, because I'm getting a compiling error.
Missing something on this? Are you sure you are in the class ebook? Let's start with the easiest thing. Yeah? Okay, I'll take a look. Okay, let's finish up, see if there are any questions. But before I move on to the next module, I'll come and take a look at your code. Okay? Yeah?
What is the test going to go over, like inheriting array list and then overloading and overwriting?
Yes, the test is going to be over inheriting from array list, overloading, overriding, all the examples of polymorphism that we have covered, dynamic binding, and I would say also method matching, but that happens during the compilation. You need to understand it, but I'm not going to ask you to do anything special about it. But dynamic binding, yes, you might have to do something special that requires your understanding of how dynamic binding works.
And then what practice exercises should we do?
So the ones that I recommended here in this presentation, definitely. Okay, these are the closest. And then the 2 other practice exercises that I released at the beginning of part 2 of our module 3. Okay? Yeah?
Can you go back to is matching book class?
Absolutely. There you go. So we add a method is matching to the class book. If you have questions that help you get a better idea of what to expect after the exam, shoot them now as well, okay? In the meantime, I'm going to go and check his code real quick, see if we can debug it in like 30 seconds. If not, then we'll work on it another time. But
okay, so the good news is just in fact this is matching characters or something like that. But I don't want to spend like too much time doing it because I'm going to go. But come at the end of the task if you want and we'll take over it, okay? But it's nothing, like a fundamental misunderstanding or anything. It's just like a silly little parenthesis that's getting in our way, okay? All right. Let me switch now to module 4. So anything we're going to discuss from now on, not at the exam this week.
Again, big warning, I want this to be clear for everybody. Okay? Module 4, in terms of complexity, you guys are going to take a breather here. Okay? We are going to go down the slope of complexity. We reach our peak with polymorphism. I warned you since day one. Okay? So this exam coming up Friday is going to be actually, technically speaking, the hardest one until now. Okay? Module 4 is not to say that Module 4 is empty or not useful or anything like that, but in comparison, it introduces concepts, but the concepts are a lot easier. We are going to mostly use it as an excuse to practice more inheritance, more polymorphism, pretty much just keep using object-oriented programming features, okay? Without actually, how to say, stretching your brain to the limit again, okay, so that we have time to absorb the previous stuff and add just a little bit of new stuff that is very applicative in nature. So the applicative topics we are going to talk about are exceptions, and then file, input, output. So let me tell you a little bit about exceptions. How many of you know what those things are, by the way? Okay, I'm just waiting my time to see when people are not going to raise their hand anymore. These are floppy disks. I doubt that many of you use them, but at least you still know what they are, right? You don't think this is a 3D printing of the save icon or something like that? That would be bad. But for me, I guess. So let's say that you are writing a program that has to read a removable medium, okay? So a USB stick or something like that to be a little bit more modern. But you don't know if it's in there or not. You don't know if the floppy is in the drive or not. Somebody can also open the latch of the drive while you're reading the floppy, yank it out, something like that. Stuff can happen in the physical world that's going to affect your code. Okay? Until now, we have lived the sheltered life. In COP2512 and COP2513, we have those academic examples where everything is self-contained. So nothing can interfere with the execution of our code. But the more you get toward a realistic application, the more you interact either with real physical systems or with other computer systems that are beyond your control. And those other components of your application, call them microservices, call them servers, call them whatever, they can crash, they cannot respond, they can do all sorts of things that are completely beyond your control. Okay? So what do we do when something like that happens? When I'm in the process of reading a file from a floppy disk, and then suddenly the data stops coming? What do we do when we are exchanging API calls with a microservice, and then suddenly there's no response at all? The request all time out. We have to recover from that. Until now, we didn't attach a lot of importance to recovering from errors. Okay? We tried to detect some situations that were, for example, out of range parameters, and this is the whole thing we did to try to make our code more robust. But those kind of errors, we just didn't have the tools to handle them, and I forgot to pin my mic again. So we didn't have the tools to handle those errors at all. That's what exceptions are going to be to us. Exceptions are going to be the tools that we need to handle any form of accident that happens at runtime while the code is executing. And the goal by handling it is to be able to recover gracefully. Okay? Your component of an application should not crash because the microservice failed to answer within 5 seconds. You should just reattempt later, or you should inform the user, or you should put something in one of the log files. Okay? So that's the menu for this module. That's the main concept that we're going to discuss about, exception. So these are the learning objectives from the textbook, as usual. I'm not going to go over them one by one because right now they would not make much sense. But this is just to give you an idea of what the lecture is going to be really focusing about. As usual, this is what is highlighted in red. We have 2 pages that are on the topic of exception. So it's going to be pretty much the majority of this module, the majority of the reading assignment, and the majority of our lectures. And then, at the end of the reading assignment, and at the end of those lectures, we are going to switch to another topic. So there are going to be 2 distinct topics in this module. The first one being exceptions, the second one being file, and more specifically text files, input, output. So how to read data from a text file, how to write data to a text file. There are two types of files, okay, roughly speaking. Text files, where the structure is, we have line of text after line of text, each marked by a special character that means this is the end of a line. And a line of text is made of a sequence of characters. And then we have, more generally speaking, binary files, where we don't have to have just characters and end-of-line markers. We can have just whatever we want. For example, an image would be definitely a binary file. Okay? So all of this is independent from databases. Databases are another way, a higher level way to store information. Look at text files and binary files as a very basic way to put something on disk. Okay? What are we going to learn to do with text files? We're going to learn to read and write inside of them. To write into them, we're going to discover a new class called the print writer. And I'm going to grab my laser pointer real quick. There we go, the print writer. So that's going to be a new one. To read from them, we're not going to have to learn a lot. We are going to reuse our old friend, the scanner. The scanner that we have been using all of this time, to read from the keyboard, can be used actually also to read from a text file, to read from a connection to a HTTP URL, for example. So we are going to just reuse the scanner in that context, use it to read from text files. And that's the menu for our module 4. So as you see, exception is going to have maybe a little bit of concepts in it, but these are like applied concepts. How do we handle, what tools do we use to handle, problems at runtime? And then we are going to introduce the little methods and class that we need to be able to interact with files. And why did we choose to interact with files now? Because when you interact with files, this is such a perfect context for applying exception. Okay, because again, you can try to open a file on disk. Maybe the file has been erased. You can try to access and read the content of a file, but maybe you don't have permission to read the content. So we are going to be able to deal with an application domain here where all of those exceptions are very concrete in nature, and they can and will happen. Okay? So that's the plan. So as usual, there's going to be a reading assignment. It's not optional. Chapter 12, okay, in this case. We're going to have a PQ and a GQ. That's going to be the last one of the semester. We are going to have some practice exercise, so I'm going to release them early. The first two practice exercises that you see on this slide are about exception. The second two other practice exercises are about file I/O. Again, that doesn't mean that these are the only relevant exercises in the textbook. The only reason for which I'm still using this textbook, as a matter of fact, is because it has such a huge amount of exercise in them, and you can even find the solution online. Okay? So the bottom line is, if after those 4 exercises you feel like you need more practice, don't hesitate to come to office hour, ask us, or pick an exercise from the book, okay, and try your hands at it. And if you are stuck, bring it to office hours again. We'll work on it with you. All right. So let's get started. So let's start by painting the picture in a favorable way, okay? Trying to show, and actually I don't have much negative to say about exception. Exception are really a neat mechanics. So let's try to kind of motivate the use of exception by looking at what we have been doing since COP2513, what we have been doing without exception as a tool, okay? So here's before exception handling. We have a class quotient. Is going to somehow compute a quotient at some point, pretty sure. It has a main method inside of it. We have a scanner that's declared here. We have a system.out.println that invites the user to enter 2 integer values. We read N1 and N2 by calling input.nextIn. So input is the name of our scanner. So all of this is, if you use Java in COP2512, then it's early COP2512. If not, then it's early COP2513, beginning of the semester. We are reading stuff like that from the user as well. Okay? And then we display the result of this colossal program, which is N1 divided by N2 is, and the result of dividing N1 by N2. What could possibly go wrong with this? Yes, that's true. So have we learned to handle that until now? No. Now, every time, I don't know how other people did it in Super 2512, but in 2512, I tell my student, if you say to the user, give me an int, for now, we're going to assume that the user is going to play nice with the program, and is going to give us an int, okay? But you're right. The first type of problem that can happen is the user types hello, enter. That's not an int. And that's exactly what we're going to solve, give me 4 slides, okay? So you're ahead of the curve there. What else can go wrong with this? Yeah?
Divide by zero exception?
Mm-hmm. Yeah. So for those of you who are going to go in cybersecurity, develop that habit, okay? Look at some piece of code and try to think immediately on how you can break it at least. And then if you can break it, try to think about how you can exploit breaking that code. But it's a good way to get started, thinking about those kind of things. And it helps you also if you don't want to become a security specialist, just helps you program better, okay? And understand what's going on. So absolutely, there can be a division by 0. And by the way, the textbook tells you this is not going to raise an exception. This is what an exception looks like, by the way. But these are exceptions that we have not been catching. So some of you encountered this. Sometimes you were running your code, it compiles fine, but when you run it, it crashes, and there is that word, exception, blah, blah, blah. Something happened at runtime that I didn't expect. That's what it means, okay? So that's what we are going to learn to handle, but we are going to learn to make it so that our program reacts to the exception, instead of letting the Java virtual machine, crash and just tell us on the screen, oh, by the way, this is why I crashed. Yes?
Is there an exception class that we can? Okay.
Yeah, definitely. There is not only one, there is a ton of exception classes. Okay, very good question. And this is what we are going to use to actually pretty much control those unexpected occurrences at runtime. Okay, so another thing that's going to be good about exception is that exceptions are going to show you that there are most of the neat tools that are out there are going to come to you packaged as OOP pieces of code. So is there going to be a class exception? Yes. There are going to be subclasses of exception. We need to know about inheritance. We need to know about polymorphism. We need to know those things just to be able to use effectively exceptions. Okay? So that's what I meant by this module is going to be a little easier. We're not going to try to just pile up more things in a desperate rush towards the final, but we are going to reuse continuously what we have covered until now, so that by the time the final comes, even if you are a little shabby right now on polymorphism, by the time the final comes, you'll be a lot better. Okay? So just a side remark here, in the textbook you can see somewhere that they say division by 0 doesn't cause an exception. Yes, it does. So there is a little trick here. If you attempt to divide an integer by 0, the integer division causes an exception. But if you try to divide a floating point number by 0, what happens? Have you guys covered that in 2512? Or do you remember it? NaN, nan. Not the delicious bread, it's spelled differently anyway, but not a number. This is a special value for floating point number, okay? It's part of the standard on how we represent floating point number in computers, and that special value, just like plus infinity, minus infinity, and stuff like that, right? That special value means the result is not a number. It's not a valid number. So if you try to do an integer division by 0, you get an exception, your program crashes. If you try to divide a floating point number by 0.0, so you do a floating point division, okay, then what you get instead is inside of your number you get that let's call it a constant, nan, okay, that's going to pretty much be the result of your computation. But nan is almost unusable. It means that pretty much you made a mathematical error somewhere in your formula. Okay? Yeah?
So it actually puts this non
Yeah.
into whatever variable?
Yes, absolutely.
Is it like null or function?
No, it's not exactly like null, but it puts that special value nan inside the variable, like you said. And if you try to add something to nan, for example,
Functioning like
you get nan. Say that again?
interrupt you. It keeps it functioning like
Yeah, it keeps working. It just carries around that mistake result. You see what I'm saying? So you divide by it, you divide to it, you apply division to it, or whatever you do. Every time you try to do more operation, more mathematical operation with nan, you get nan again. Up to the point where you finally, for example, try to display that result. And if you display it or write it in a file or write it in a database, what's going to appear on the screen in the file or in the database is nan. And then you're screwed pretty much. Okay, because now there's no way to hide it. There was a problem somewhere, but tracing back where that nan comes from can be tricky. Okay, you have to review the whole chain of events that led to, for example, writing the result on this file. So it's pretty fun. Not. But this is actually preferable, in my modest opinion. It's preferable.
That's what I was saying, because it actually gives you an error, right?
Yes, right away. It crashes right away. It tells you what you are doing is wrong. The buzzer sounds. It's right when I do this division. Okay? So now I can debug more efficiently. So yes, the textbook say it doesn't raise exception, but it does raise exception in the case of integer division, not in the case of floating point division. Just little side remark. So we have a piece of code here that does something potentially useful, even though it's not much, but it has the potential also to fail, and interestingly for us, it has the potential to fail at runtime, not at compilation time. At compilation time, Java has no problem with n1 divided by n2. This is perfectly all right. It's just that if n2 happens to be a 0 at runtime, we are in trouble. So the problem with this is that it's brutal. When the exception reach your console like that, when it displays exception, it's too late. The whole application is down. Does it matter if you are writing 5 lines of code just to run quickly to process a file or something like that? Not really. You have a bug like that in a server or in a microservice, it's a lot more relevant, because you have like other things that your microservice is supposed to do and provide. You have an entire API that you're supposed to respond to. And because somebody made a call to one of the elements of your API with a wrong parameter, for example, now you completely crash. So the service is down. So it's great for denial of service, not so great when you are on the programmer side implementing those services. There's no opportunity to recover from error. Once you trigger the exception here on the console, again, it's too late. The application is already down. So how can we fix that? Well, we can try to fix that with an if statement. And that's pretty much all we had until now. Yeah.
I heard this one story that this guy named his bank account with an emoji, and it crashed the entire bank just because he couldn't process the emoji.
Not to self. No, but it's, I don't know if it's true. I haven't heard actually that one. But that's, how to say, I'll show you something like in a few slides. Okay, you're going to see this is the same spirit. This is the spirit of, like, you know what we use as testing for our code just to make sure our code works? Well, it's the same mindset that you do when you try to break something. Like, what are you letting me get away with? If you ask me to enter my name, for example, in a form, I'm going to enter a name that is 516 characters. Why? Just to see if you have like a limited string buffer or something like that, I'm going to overflow it. What's going to happen, right? So it's really like that testing the boundaries that's really interesting in both cybersecurity and programming. But anyway, but that one is interesting. I never heard it before. Thanks. So how can we try to prevent that in our code? Okay. If statement, so same code than before, but here I say if n2 is different than 0, then do the division. So this is a normal part of the code here. But I added an if statement to detect a potential runtime error, and then the else part is pretty much the error handling. Bear with me for now, our error handling is going to be in most cases, display an error message, but this is really not the best we can do. So the last example I have here right now is going to show you a more concrete and a more real world like, example of exception handling. So bear with me for like a few more slides here with those silly examples. So we enter two integers, 42 and 0. Divisor cannot be 0. Well, it's not an exception. My application didn't crash. It displayed an error message on the screen, but it didn't crash. It's still running. So if I add some more code here after the else statement, I would still continue trying to do something as much as I can, even though I was given bad data. Okay? So we can prevent the error before it happens. The code for handling the error is kind of mixed in with the code, the logic of the application. The logic of the application was get two number divide. Now I have this if statement, that else that is kind of in the middle. Okay, so that could be a weakness. Okay, and console logging, displaying error messages by using system.out.println, that just stinks. Okay, I know we have been doing that non-stop for last semester and this semester. We're still going to do it. I just want you to have a heads up. When you are actually working on a project, you're going to be working on different types of app, like desktop app, web app, a mobile app, etc. These things, they don't even care about a console. Most of the time, they don't have a console. So think about every time we have been displaying something on the console, in your future careers, that would be send something to the log file. Okay, that would be a much more realistic scenario. So we display on the console here because it's easy, it's intuitive, it's very interactive, it's really fast, but really most applications, they just put into a log file, whatever happened that is worth mentioning, and then they move on. So logging to the console, yet again, not a great deal here. So let's switch to a method now. So now we are encapsulating the logic of our division into a method named quotient, okay, that I'm going to write in the next slide. So the structure of the code is the same, but it's a little cleaner because now I read data from the user, I compute the quotient, and then I display the result. So when I look at this code, I understand the logic, the business logic of the code, and I don't have to worry about, error handling. I kind of delegated that to the method quotient. So if I look at the method quotient, this is what I have in it. Take two number. Guess what? The goal is still to return number 1 divided by number 2, but I have my error handling here. And this is what happened here when the error is triggered. Divisor cannot be 0, and then the program stops. This is a system.exit one here that does that. So my application didn't crash. It committed suicide. I don't know which one is the best, honestly. Okay, I would say probably none of them. It's like a self-crashing, self-induced crashing, something like that. So it's still a problem because this method has to return something. If I want the method to complete, it has to return something. It has to return an int. But there is no sentinel value for me. Nobody has told me, oh, by the way, if you return minus 1, 2, 3, 4, 5, that means that you encountered an error condition, and whoever called you is going to know what to do. No, whoever called me said, I call you with two numbers, you give me back a number. There is no mention of a protocol for us to handle errors. And that's going to be like that for most method, square root and whatnot, okay? So anything that returns something, generally you don't have the luxury of a sentinel value in the range of returned potential values. This is brutal again. The server doesn't crash, the server just decides to stop working. And we still didn't give a chance to whoever called the method to recover from their mistake. Because the mistake is in the hands of whoever called this method. They gave me a 0 as number 2. That should not have been. And we have no way to fix that. So, and console logging is still bad. So pretty much, do we have anything that could help us do things a little different? Yes, we do. I'm going to just show you the slide, and then we are going to stop here and then resume exactly here next time. This is how we are going to write the code when we use exceptions. So the quotient method here, taking number 1, number 2, is going to still detect if number 2 is 0. That's how we're going to know something is wrong. And then we have this new syntax here that is going to create an object on the fly of a class named arithmetic exception. So again, OOP stuff. And that's going to allow us to open up a new channel. That's the only thing I want you to remember from just looking at this code that's not been yet explained, okay? It's like the way I told you the method has to return an int. And there's no way for it to say, alert, there is a problem. That's exactly what exceptions are. Exceptions are another way to return from a method that is bypassing the normal return mechanism. So I'm not going to get an int. Instead, it's like the alarm is sounding, and I'm getting a signal that says, wow, you tried to divide by 0. So when I call a method now, I'm going to have a choice. I'm going to be able to always call the method and get the return value, but I'm going to also be able to call the method, listen for the alarm signal, and if it rings, then do something else. All right, let's close it here for now. We are running out of time. Thank you. And we'll stop there next time. So get started ASAP on those practice exercises, please, okay? Yeah, what's up? Hold on, let me stop the recording real quick.